Right, so on to page 3. So now this is something different. We're looking at fractional exponents. Okay, so take a look at these problems. Our exponents have now become fractions. So just a little bit of a step up, but nothing too intense. All right, so one hint for fractional exponents is you want to take out the smallest exponent. Okay, that's generally what we do. All right, so let's look at part A. Which one of these values is the smallest fraction? Well, the smallest fraction, you might be tempted to say a half, but remember, the negative numbers are the smallest numbers. So we're going to be taking out or factoring out x to the negative half power. Okay? So the question is, what is left over? So when I factor out x to the negative half power, from x to the 3 halves, what do I have? Well, the way I like to think about it is I like to think about, well, if I was to multiply this back in, how would I get 3 over 2? Well, when we multiply things back in, remember, we keep the base and we add the exponents. So what I'm trying to figure out is what number plus a half would give me the original 3 over 2. Well, 4 over 2, if I add that to a negative half, I'll get the original 3 over 2. So 4 over 2 is the exponent I'm looking for. Okay, you could check that if we distributed this back in, keep the base, add the exponents, we would get x to the 3 over 2. All right, so then minus, so now we're taking out a negative half from a half. So go ahead and try to see if you can figure out what the exponent is going to be. All right, so let's see. So same idea. We want to end up with, well, this time we want to end up with a half. So what do we add to negative half to get a half? Well, 2 over 2. If I add a negative half to 2 over 2, I should end up with a half. So there we go. That's the exponent we're looking for, 2 over 2. And then plus, that's the plus sign right there. Bringing down the plus sign. We take away x to the negative half, and what's left over is just that 2. All right, so let's go ahead and see if we can simplify this. Oh, I just made this really ugly. No. Should have done that on a sticky note next time. All right, so I'm going to rewrite our equal sign here. So we have x to the negative half, and let's simplify the inside first. I can simplify this fraction. 4 over 2 is the same as x to the second power. So then minus 3x to the 2 divided by 2 will just be 1. So you could write the 1 if you want to, or you can leave it without the 1. Most of the time we choose to leave it without the 1. And then plus 2. All right, continuing down to this side, I'm going to jet my equation out to that way. All right, so when I look at this, I need to ask myself, can I factor this further? Well, this is a trinomial here. So can we factor this trinomial? Let's go ahead and give it a go. So let's see, can we factor it? This time I will bring out my sticky note so I don't mess up my work. All right, so we're trying to factor x squared minus 3x plus 2. Since the x squared term does not have a coefficient, well, it has a coefficient of 1, we can just go ahead and plop the x in right there. And then we know that because this is a plus sign, the signs are both going to be the same. So they're either going to be both pluses or both minuses. Since this is a minus, that means both of these should be minuses. So let's take a look at the factors of 2. Factors of 2 are, well, 1 and 2. Can we add 1 and 2 to get 3? Yeah, we can. So we have a negative 1 and a negative 2. If you wanted to FOIL that back out and check your answer, you can go ahead and do that. Or distribute that out. So x minus 1, x minus 2. Okay, we are super close to being done. There's only one small, eeny, weeny, tiny, miny problem. That negative exponent. No negative exponents. So let's go ahead and use the rule to get rid of that negative exponent. And there we go. Lastly, we could just combine these by multiplying across. Because remember, we can put any number over 1. And when we multiply across, we'll end up with this. Okay, there we go. All right, on to the next one. So part B. Let's see. This is a binomial. It's got 2 terms. So we got this term here and this term here. So as usual, I'm going to look and see, do they have anything in common? Well, both of these terms share that x plus 1 binomial in there. Okay, so I know I'm going to be pulling out an x plus 1. The question is, to what power? Well, remember our rule is we're going to choose the smallest exponent. So what number is smaller, -2 or 3, or a third? Well, remember the negative's the smaller one, so we're going to pull out -2 over 3. Now, what is left over? Well, when I pull out -2 over 3, it's just going to be 3 left over for this term. So let's copy down that plus sign. Now, what is left over when I pull a -2 over 3 out from a third? Well, we're going to do the same trick we did for the last problem here. This time I will use a sticky note. So it's sort of like reverse engineering here. So if I wanted to multiply this back in, I want to end up with a third at the end. Oops. Okay, so what exponent could I add to 2/3 to get 1/3? 3/3. Because if I add across, that'll end up with 1 over 3. So this is the exponent I want. And as usual, you could multiply this back out to see if you get what you originally started with. All right. Simplifying. Remember, we need to get rid of that negative exponent there. Always got to get rid of that, unless you are told otherwise. But at this point in time, let's get rid of that negative. Okay, and then simplifying over here, 3 divided by 3, that's just 1. So that's going to be x plus 1 to the first power. Can we simplify any further? Yeah, if we drop these parentheses, then we can add the like terms of 3 and 1. Let's go ahead, drop those parentheses. It's going to be 3 plus x plus 1. And then we can add the like terms of 3 and 1. And we get a 4. So that's going to be 1 over x plus 1 to the 2/3 times x plus 4. And lastly, just like we did last time, let's combine these into one fraction. So it's going to be 1 times x plus 4. So it's x plus 4. All over x plus 1 to the 2/3 power times 1, which is just going to be itself. All right, moving on. Next, factoring. Okay, so this is factoring by grouping. And we use the grouping method if we have 4 or more terms. Okay, so let's take a look. How many terms does this problem have? 1, 2, 3, 4 terms. All right, so generally what you do the first time you try to factor is you group the first 2 together, and then you group the second 2 together. All right, so I'd go ahead and group this, and group this. But we have to be careful. If I just sort of blatantly put down these parentheses, I have actually changed my problem. Let's go ahead and see what I mean by that. So I'll rewrite the parentheses I did. Okay, and I'll erase this. So let's see what I mean when I just put down those parentheses. If I distribute in this negative here, what do I get? I get 2x cubed minus 2x squared minus 6x, multiplying the negative, minus 12. Is that what I originally started with? No, it's not. Be very careful. See this minus 12? I originally started with a plus 12. Okay, so you need to be careful when you add in the parentheses for the grouping symbol. If there was a subtraction here, you need to change the symbol on this. If it was a plus, it becomes a minus. If it was a minus, it becomes a plus. Let's go ahead and see if that works this time. Do I get what I had originally? Okay, so when I multiply this out, negative times a negative 12. Ah, there we go. I get back that original plus 12. Okay, so the thing to learn about this is when you create the grouping signs, the grouping parentheses, and you have a minus here, you need to change the sign. If it was a plus sign, you don't need to change the sign. Okay, but it's always good to just give your work a quick check to make sure you're factoring correctly. All right, so let me rewrite this a little bigger. With our grouping parentheses. Okay, so now what we're going to do is focus on each individual parenthesis group and see what we can take out that they have in common. So this group here, what do they have in common? Well, they both have a 2, so I know I can factor out a 2. And then they both have an x to the second power I can pull out. Okay, so what's left over? Well, 2x to the third power. The 2's gone. So we're just left with x to the... Well, we took away 2, so there's just 1 left. You can write the 1, or you don't need to write the 1. Okay, copy down the minus. 4, when you factor out a 2, you're just left with a 2. And then factor out the x squared, we're just left there. Okay, so that was the first one. We factored that. Copy down the minus sign from there. Okay, looking at this term, do they have anything in common? Well, 6 and 12 are both divisible by 6. So we can factor out a 6, and what's left over? X minus, okay, well, when you factor a 6 out of 12, we're just left with a 2. All right, so now let's take a look again at these two terms. Do these two terms share anything in common? Well, they share the x minus 2 in common, so I know I can pull out the x minus 2. They both have an x minus 2. And they both have an even number, so I'll pull out a 2, factor out a 2 there. All right, so what's left over? From this term, if I take out a 2, I'm just left with an x squared. And then when I take away the x minus 2, just the x squared remains. So copying down the minus sign. Let's look at this. When I take away the 2 from the 6, I'm left with a 3. So remember, we're factoring, so it's multiplication. And then when I take away the x minus 2, oh, that's it. I'm just left with a 3. Okay, once again, remember, you could multiply all this out to make sure you get what you had originally, just to check your answer. Okay. So we're left with 2 times x minus 2 all over x squared minus 3. You know what? Let's check this. Why not? Is this really what we have? Let's check. 2 times x minus 2 times x squared minus 3. Okay, so multiplying this out, I'll distribute the 2 in. And I'm going to get, well, 2 times x is 2x. And then 2 times negative 2, negative 4. And then let's bring down the x squared minus 3. Okay, ooh, these are two binomials, so we're going to use FOIL. So let's do the first two together. So 2x times x squared is going to give me 2x to the third power. So that was first. Let's do outside. 2x times negative 3, negative 6x. Let's do the inside. 4x times x squared. That's going to be negative 4x squared. And then lastly, multiplying the last terms together. Negative 4 times negative 3. Voila, positive 12. Huh, this looks almost like what we originally started with. So if I just switch some of the terms around, which you can do as long as you keep the sign with it, we will have what we originally started with. So minus the 4x squared minus 6x plus 12. And there we go. We were right. We factored it correctly. Yay. Okay, one more to go. And then we're done with 1.3. Okay, let me zoom in. So it says first factor over the integers, then factor over the real numbers. Okay, so we have to kind of remember here. Integers are the numbers that are, fractions, whole numbers, the ones you normally think of. Okay? We don't include irrational numbers. So for integers, That's the symbol for integers. We include something like a fraction for negative numbers, things like that. Real numbers, okay, so we do the bold R for real numbers. That's when we can start to include, we have half, 0, but then we can include things like the square root of 2 and so on. Those weird sort of numbers like 3.14 and stuff. Okay. So first we're going to try factor with numbers that exist in the integers, the nice numbers, and then we'll try factor over real numbers. Okay. So this one is asking me, it looks a lot like a difference of squares, maybe. You know what? This is prime. Over the real numbers, there's no way to factor this, because I would need to write it as x squared minus 3. That would be something times itself. So x, let's see. Well, if I did, let's try minus 3 plus 3. Maybe that'll work. Let's check our answer. So if I take the first one, I would get x squared. Outside, I'd get 3x. Inside, I would get negative 3x. And last, I would get minus 9. So that comes out to x squared. Well, those guys cancel. And I'm left with minus 9. Shucks, that didn't work. Okay, so actually this one, we cannot factor it over the integers. So over the integers, what would we call this? This is prime over the integers. Okay, cannot factor in integers. But let's see. The problem with this one is when we multiply it in the end, the nice thing is, for this one, the inner terms canceled out, which gave us that nice binomial. But when we multiplied 3 times 3, we ended up with 9. What I want is a number that when I multiply it together, I get back 3. Is there a number that when I multiply it together, so let's see, I want something times itself that gives me 3. Try pause and think a moment. What times itself gives me 3? Go ahead, look at these numbers here. See if there's any that exist here that if I multiplied it to itself, I'd get 3. Okay, the hint is going to be this one. Go ahead and see if you can figure out something with a square root. Okay, all right, given some time there. So the answer is going to be square root of 3 times the square root of 3. You might be like, what? Well, remember, square root of 3 times the square root of 3, if I rewrite this, change those radicals to exponents, that would be 3 to the half power times 3 to the half power. Keep the base, 3, and add the exponents. So a half plus a half, that's going to equal 3 to the, well, half plus half is going to be 2 over 2, which is the same as 1. So that equals 3. And there we go. We found the number that when we multiply it to itself, we get back 3. So the number that's going to go in here is square root of 3. Okay? So x squared minus 3 is prime over integers, but if we expand the kind of numbers we're allowed to use, so for example, we're allowed to use radicals and whatnot, if we expand it, then we can actually factor this. So it's factorable over the real numbers, because then we can include radical choices. Okay, so be careful when they ask you to factor if we're factoring over just the integers or the real numbers. Most of the time, we ask you to factor over integers. But if you ever have a question about that, please feel free to ask me. Okay, so that's it for 1.3. Here's your written homework that is due at the end of the week. Please write that out neatly and upload that to Dropbox and Lima.